In this video, we will talk about the two-dimensional arrays and the way we represent a 2D array. I have taken an application for us. This is the cholesterol computation, total cholesterol. Okay. The way it is computed is it has three components. If you check with the doctor, he'll show you it has three components. One is the HDL, the other is the LDL, and the triglycerides. Okay, and I have represented that in one dimension. Okay, as you can take 1 second, sorry, here. In the other dimension, I have listed the indices representing the year. Let's say, for example, 2005, 2006, it goes on, okay? 11, 12, 13, 14. So this until 2014, all right? So these indices represent the year, and this rows represent one of them is the HDL, LDL, and the triglycerides. Our objective is to compute the total cholesterol, okay, using the formula HDL, LDL, and the triglycerides. Usually the triglycerides is we take only 1/5 of it. Okay, so objective is to add for each year. Okay, objective is to compute the total cholesterol for each year, and we learn some things in that. Okay, and now the question is, we'll define this array as, let's say, let's keep it as data. Okay, that's the data we have. It has 3 rows, all right, and we'll make it 10. Number of years is the 10. So that's how we define. We can just define it as the unsigned integer, right? Or let's make it signed integer or a short, whichever. It won't work. Unsigned won't work because unsigned char won't work, because the value will exceed sometimes more than 250. Okay, so this is not useful. So we can take it to a short, unsigned short. All right. So we'll go back to our system. 1 second. Let me close it. I'm going to log into our system. Once again, need some adjustments here and there. Okay, getting there. Just hang in there. Okay, I have made it. I log into our system. All right, 2d.c. I'm writing the program right as we speak. So my unsigned short data 3 and 10. We can increase the year to more than that if you want to define num years, okay, to 10. So that is a way to define a constant, okay. This is the constant. All right. And we'll also define, best thing is to define SDL is index 0, okay. Define LDL 1, define, I'm just triglycerides as 2. So those are the indices, and we need to array. I'll just use it for that to, okay. The other thing is we are going to use random numbers to fill in the values in the array, okay. Now if you go back to our blackboard, we need to fill in the values, right? 1 second. So we need to fill in the values. The values could be 30, 120, I'm not sure, I don't know, 100 maybe. So let's fill in the values using, okay, fill in the values using random number. And we know the SDL, if you look at the SDL, let's give a range from say 20 to 50. This is the sample, okay, it can exceed 52. LDL, let's make it a range of 100 to 200. Again, it can exceed or lower this. And triglycerides, let's give a range from 50 to 100, okay. So these are the ranges we have. Pretend we have this range, okay. So we'll use random number to fill in the values using this range, okay. How do we do that? We know in the, if you go back to the module, I've listed a topic on how to give a random, generate a random number on a range, okay. Let's do that here, right here. So how do I do that? First, remember we said srand time null will give you the seed. All right. So how do I fill in the values? For I equal to 0, I less than years, I plus plus, okay. Let's put it data. We said SDL, right? SDL is 0. First in I equal. So this gives me, I'm filling the SDL row right now. If you go back to our board, I'm filling this value for now, okay. SDL index is 0, I equal to 0, that is 30, right? But I'm going to fill in with randomness, okay, with random. So how do I do that? If you go back here, we say the low is what? We said the low is SDL is 20, right? If you go back here to SDL is 20 to 50, right? So how do I do that? 20 to 50 plus rand 50 minus 20. Go back to the module, okay? See the module. And how do we do for LDL? Is we say it is 100, right? 100 to 200. 200 minus 100. So that is the range for the LDL. And then the triglycerides, okay? Triglycerides. We say it is 50 to 100. Alright? If I go back here, if you check the whiteboard, it matches there, right there. LDL 20 to 50, SDL 100, we saw all that, okay? Go back here. Now go back to the program. Alright, so we filled in the values in the data array. Let's print it now. Filled in the values. Now print the values. How do you print the values? So same as that, same the for loop. Alright. Print SDL. Alright. Let's put that data SDL I. Right? So we use a for loop to fill in the values, and we also print the same LDL. Alright, then triglycerides. Okay, then we need to put a end of print line. Okay, so here everything is here. If you go back and print it, oh, there's nothing else there. Okay, okay, very simple program. Okay, usually the printf should be well within the for loop or any statements. Alright, so I filled in with random values and I'm printing it. Okay, now let's go and check it out if it's printing or not. Ah, look at that, there is no compilation error. That's good news. A.out. Alright, look at that. We have SDL 45, LDL 140, and triglycerides 87. So we, for each year, we printed the values. Okay, and now that we have printed that all the values, now the next question is, let's keep it this way. We also compute the total cholesterol. We just printed, but we didn't compute, which is SDL plus LDL plus 1/5 of triglycerides. Glycerides maybe. Triglycerides, something like that. Okay, so we have everything now, so we need to compute. So let's create a local variable, unsigned short as total cholesterol, like TC. Okay, so how do I do that? TC equal data SDL, alright. SDL we added. We can also add in the data LDL, alright. So we added the SDL and LDL. We need to compute the 1/5, right? So I'll do TC plus, okay, data triglycerides 2. Oh, I. Alright, we got that. Now we need to, it should be 1/5 of that, okay, 1/5 of that. Now we need to print the TC and verify. TC equal, alright, integer. We usually print cholesterol as integer, we don't print as float, is TC. Alright, print total cholesterol. I just named it. Okay, let's see what the values are from here and take it from here. Okay, let's print it again, compile again. Oops, we have some problem. It says what is TC? I don't know what TC is. Let's go. 33. There you go. So you didn't have the that. Okay, let's see what else we have error. We have a lot of errors. Okay, sounds good. I made some major problems here. Okay, okay, so sounds good so far. Okay, so again let's go compile it and see some values. Okay, we have printed. Now let's check if the values are true or false. All right, let's take it from here. Let's take a simple one. Okay, triglycerides here, 62. 1/5 of 62 is what? Should be 12. 12 plus 192 is what? 12 point, basically 12.4, and 192 is plus 12 is 2204 plus 22. I'm sorry, this is 14, right? Why it is showing 192? Or we are not computed correctly here. Okay, I just found, if you go back here, I just checking why our values are wrong. If you go back here, it's very wrong. It's not taking 1/5 of this, right? So 120 plus 49 is 169. What happened to 1/5 of 50? And there's a problem everywhere, right? So I found the problem here is because I used a dummy expression here. It should be TC not plus, TC equal. TC equal, TC plus. Then you get the right answer. Compile it. Now if you run it, you should be able to get. Now if you see 164 plus 30 is 194, and 1/5 of 15 is 18. So we got that. Let's take this example here. Okay, let's take this example. Let's go back and let me pause the video 1 minute. Okay, I got a space. Let's take this example here. Oh boy. Okay. Let's take this example. 30 we have plus 131 plus 1/3 of 60, 1/5 of 63 is 63 by 5. Okay. So 131 plus 30 is 161 plus 1/3 is what? 1/5 of 63 should be 12.6, right? But it only took the 12 part. 173. Because why it dropped that? Because of truncation. Okay. Remember what happened here? Let's go back to our program. This is unsigned short over 5. When you do that and when you add up, it's this integer. When you divide that, the resulting value is an integer because it throws away that guy. So that's, if you take another example here, let's take another example. 74 here. If you see here, 23, 87, 74. Okay. Let's erase this. So we saw 23 plus what? 187 plus 74 over 5. So this should be 23 plus 210 plus this should be 14.8, which should be 224.8. We got 224. So it dropped the truncation. See that? Truncation. But if you want that 0.8 to be included into that, right? So the net value is 225. How do you do that? Interesting problem, right? Okay, that's where we need to talk about what is a function called round. We need to round it off. All right. So you might ask, what is round? If you go back here, man round. Let's go back to mathematical function. It's a system function. Round. If you do it, it says round to nearest integer. There are a lot of functions, but we will just take round f maybe. Okay. And it says link with minus lm. Alright, so we'll need to do these two things. First is to get, there's also a math function we need to include. Okay, so three things to use that round function. So let's do that. First thing is to include math.h. Alright. The second step is to, here the triglyceride over 5th is there, right? So we need to round f, convert that into a float. Okay, and this is quite not enough, because what round, okay, let's see how this works. Okay, and second thing is, this is still an unsent short here. This is unsent short. This is again maybe unsent short. This still, when you divide a unsent short with unsent short, you still end up truncating the values. So we need to make sure one of them is a float. So you can do that. Okay. Now when you go back to our board here. We had talked about truncation. So I'll erase this guy. Here, when you have 16, let's say by 19 by 5, when you round, it doesn't matter whether you round or not. 19 by 5 is what? 3.8. Because integer over integer results in truncation, 0.8 will go away, you still get 3, and you pass 3 to round function, and round function cannot do that for you. You need to pass 3.8 to round, not just 3. So for that you need to either convert either 19 to float or both, or just the 5. Okay, so I'm making it 19 by 5.0. Then you say round. What happens is it result in round 3.8 will get you 4. You see that? Okay, let me explain this a little bit more. So we have done all that. Okay. Here. If you do a round just 19 by 5, you will get only 3. Because this, why? Because this results in round 3. Because this operation truncates. Okay, but if you do this round 19.0 over 5, this will result in round 3.8, because this 0.5 gets converted into float. Float over float results in float. Integer over integer results in integer. So this, my friend, will get you 4. Alright, now go back here and convert that into 5 point. Now if you do it, so I'll show you that example back again. Okay, let's say junk.c. Simple thing is write always a program for you to see what I'm doing. Alright, printf now compile that. gcc jun.c. I should do, better thing is to always do that. You got 3, not 3.8. Alright, but if you do the same thing, next line, convert one of them to 0.0. Now you compile it and run it, you get 4. See? So that is the power of round. So let's go back to our function. That's what we did here. All right, now if you run it, if you run it, you will get a perfect answer. Let's take 88 right there. 38 plus 125. Okay, let's go back to our program here. One second, let me copy this into a slide. Okay, so what the values we got? 38, 125. 38 plus 125 is how much? 163, right? Plus 88. 88 over 5 is how much? 17.6, which is becomes 18. So plus 18 gets you 181. Is the answer 181? 181. So that is the concludes our lecture on 2D arrays. So what all did we learn here? What all did we learn here? We learned how to utilize a two-dimensional array for an application, medical application, okay? Medical app. And we know how to traverse the array. We traversed the array. We used random to fill in the values. All right. We use random to fill the values, okay? And we used round function to see how that works. We tried to link with a math library. All right. So many things we did, okay? And we also used random to get a range, okay? We discussed this in the module. Go back to the module. And that is it. So we printed how these things work. So we saw a lot in this video, okay? And that concludes our video. Thank you very much.